All right.
Yeah. So
IPFS. Yeah. So
yes.
IPFS. All right. So as I was saying, the idea of IPFS in general.
Can you move your head to the center of the screen because it's going to cut off in the recording?
Oh, I see. Okay. Sorry.
No worries.
Yeah. So IPFS, the key thing is that you address content and not location.
Mm-hmm.
One of the biggest problems we have with the internet, and in fact, it's a problem with scalability with the internet, is that we address locations and not content because of IP addresses, because of DNS, because of all this stuff. It's based on where it is and not what it is.
Right.
And IPFS, the idea is you have basically a hash of the content. And because you freed yourself from the location now IPFS is free to move that content wherever it's needed.
Mm-hmm.
So you have the concept of data locality, where, for example, if you in the future, if you try to imagine a future where there's people on Mars, there's people on the moon, there's people on Mercury, there's people in orbit, there's people, everywhere.
Sure, yeah.
And you want to scale the internet up to the Mars and orbit and all that. The internet won't work at those scales because of this. The problem is the speed of light. It takes too much time for that information to get from point A to point B. I mean, email would work, but the protocols that work behind it and all that wouldn't work, not without modifications. Mm-hmm. Because the timeouts and all that, they don't take into account it takes 4 minutes for light to get to Mars and all this crap. And plus, can you imagine, going on Google and waiting 4 minutes to get the page, and then 4 minutes to reply to that, and then 4 minutes to make a query, and then 4 minutes to get the reply to, like, it would just not be workable.
Right.
So something like IPFS will replace the internet.
Mm-hmm.
Maybe there'll be internets, like location-based internets like we have today in different places around the solar system, but there will not be, I don't think it would make much sense to have the internet like it is today without some kind of IPFS component to it.
Mm-hmm.
Yeah. So the way IPFS can work around this is that if I access Google, and now the data is moved to my computer. So now if you access Google next, mm-hmm. the data is on my computer. So you don't have to go back to Earth to get that data. You just have to go to my computer, which is, milliseconds away, because I'm on Mars and you're on Mars, let's say.
Right.
And there's no issue with that. Now also it makes the data resistance to tampering. So because you're accessing it by hash, mm-hmm. you can't tamper with it. A single bit change means that the hash is completely different, meaning that it would be different content entirely. Right. So that's a major advantage of that mechanism.
So that's one of the aspects that makes it censorship resistant.
Yeah, and it's also why it's called interplanetary file system, is because it's meant to scale beyond planet Earth even.
Right.
Like forward thinking. But it actually has uses even today, even on Earth, addressing content makes a lot of sense. It's like a mix of the internet and torrents, somewhere in between the web and torrents.
Right.
You get web-like behavior, but with torrent-like data sharing.
Mm-hmm. Yeah.
And in principle, you could even build databases. You could build pub subsystems, which are trying to build on top of this. It's really interesting what they're doing. In fact, they're laying the groundwork for the future. Mm-hmm. A few hundred years from now, I guess this is probably something like this will be in place.
Mm-hmm.
Yeah, and it will be used probably on Mars and on the moon, and assuming we haven't blown up the whole planet by then.
Right. But, as I was mentioning earlier, I mean, one of my primary interests, being that I lived in China for 12 years, and I'm kind of familiar with some of the
Yes.
human rights
So
issues that they deal with in that country, and how the all the media outlets are essentially state owned, and all the internet is completely censored. And when you talk about internet censorship, even when a website isn't completely blocked, it's given cancer or it's given Parkinson's, right? Like
I
they
know.
they have like they slow down the website. They make it so that if a local company decides to build a Chinese competitor for that kind of service, that it will have a huge performance advantage. And then that local competitor, will be subject to the Chinese, self-censorship policies. So I think, and then also there's other government regimes. There's Saudi Arabia and Iran and plenty of other countries that censor their internets. So I
Mhm.
think that there's not only is there a huge market opportunity that a lot of people are just not fully appreciating in this kind of Web 3.0 technology, but
Yeah.
there's
I think IPFS may be a piece of the puzzle, but I don't know if it's the whole puzzle, if you know what I mean.
Yeah, well, the thing, like what I understand about BitTorrent, for example, is that if you go, for example, to a torrent website, like I guess the Pirate Bay, the
Yeah.
Pirate Bay now doesn't have any torrent files. It just has magnet links, which are basically hashes that point to the peers on a distributed hash table.
That's right. And in fact, that's what IPFS is in a way as well.
Yeah,
But it's global. It's like a universal thing.
yes,
It's
right,
not like one torrent. It's the whole web. It's everything.
right.
Or at least it could be that in principle.
But what I understand about a distributed hash table is that if you want to block dynamic IPs of users, seeding or be essentially peers on a torrent, right? You essentially have to block dynamic IP addresses of these home users as they're changing, because the difference between a data center, that usually will have static IP addresses for its content, dynamic IP addresses of home users or peers on a torrent are constantly changing. And so it makes blocking, it makes centralized filtering of something that's being shared over a distributed hash table very, very much more complex than, say, just blocking youtube.com, which is linked to a static IP address, right?
Yeah. Sure.
And
Yes.
so right off the bat, this technology like IPFS or BitTorrent is essentially kind of like water flowing through any hole in the
Oh
Chinese.
yeah, absolutely. So it means that if you went to Google's website with
Mhm.
your laptop and
Yeah,
then you fly on an airplane to China,
yeah.
your neighbor can now access Google if it were using IPFS.
Well, yeah, but also, I mean, since
That's
since
that's what it would enable. Now there's still a censorship potential at the ISP level. So there, between your neighbor and yourself,
Mhm.
this is an ISP because you presumably you have some DSL or fiber or cable connection of some kind, or maybe some Wi-Fi or cell, whatever it is, and that has basically a middleman.
Right.
Ideally, what for IPFS to really really shine is to remove that intermediary. Is for your Wi-Fi radio to be able to talk to your neighbor's Wi-Fi radio or something like of that nature.
Yeah, mesh networking, sure. But also, even when it comes to IP, ISP filtering, right? I feel like, again, if you have a bunch of users, let's say you go to YouTube in Canada and I'm, in China, right? Let's say that you download the content from your browser using some kind of IPFS browser, and then you
Yeah.
host that YouTube video from your computer over IPFS, which is using, like mainline DHT or Kademlia or something like that, which are very popular DHT implementations that have something like 10 or 20 million peers at any given time.
You can't block the IP, but you could.
Well,
I don't know. You could even. I'm not sure you could even block the content. Actually, you're right. You did have to cut off.
You could block, like if you have a mainline DHT with 20 million peers that are dynamic, that are constantly changing, right? I think blocking 20 million dynamic IP addresses on a mainline or Kademlia DHT would be extremely complex and problematic. Maybe it could be done. Maybe it wasn't possible.
No, it can't. Okay, so they could block the protocol maybe if they can recognize it. So they could just say, presumably they have some way of doing deep packet inspection or some kind of packet inspection.
Yeah.
And they're able to say, you're running IPFS, we're not going to allow that.
Right.
There's always going to be holes. There's going to be people with VPNs, with backdoors, there's going to be some leak.
Yeah.
And so there's going to be people with IPFS inside the country and people with IPFS outside the country, and those things will leak through.
Exactly. That's exactly right. So if you're using IPFS,
they can make it a crime though to use IPFS. That's an option for them. Maybe not a very practical one.
The enforcement cost on that would be quite high.
Yeah, not to mention they're going to need to do this sooner or later, although it might be very long before they need it.
Mm-hmm.
Yeah, but I mean, if they had like let's say China had a colony on the moon or on Mars or something like that, right?
Mm-hmm.
Like a large city there with people living there, and they wanted to connect the two. They wouldn't have many other options than to do something like this.
Exactly. So, I mean, I guess in 20 or 30 years, they're going to be forced into censorship-resistant content distribution. But, I do feel like currently the main reason why IPFS is relevant today is precisely because of China's 800 million internet users, right? There's 800 million people that are behind a firewall. And so today in 2019, the primary use case, because YouTube is free, Facebook is free, all of these web services, Amazon Web Services and Azure Cloud and all these other cloud providers, they're already free for the most part, right? They have some basic account and you can use all of these cloud providers. But again, as soon as you go to China, all of these web services or websites or things that are just not favorably viewed by the Chinese government are either blocked completely or they're suffering from severe performance deficits that are artificial, right?
So that clearly IPFS in that context would immediately get around that.
Right.
No question about it.
Exactly. So that's kind of where I see an immediate use case for it, again, in all of these countries where they don't have very liberal policies on sharing information, and which is a fundamental human right, right? So people do have a right to share ideas via any medium, regardless of frontiers. I mean, I'm paraphrasing Article 19 of the actual Universal Declaration of Human Rights. So it's a basic thing that all governments have already agreed to, that this is a fundamental right. And I feel like IPFS currently has a major advantage over any other technology in actually, sort of providing people with this basic fundamental human right.
Yeah.
And so that's its primary use case. Now, the other major problem that I see with IPFS is, how is content indexed? How do people search the IPFS network for content that they want?
I don't think that's IPFS itself. IPFS is kind of like think of it as a interplanetary file system. It's a file system.
Right.
It's just a place to put blobs of bytes.
Right.
Now, you can create blobs of bytes on top of that, which are an index.
Mm-hmm.
So you could, in principle, use that data store as a foundation for a database.
Okay.
Now, for a database to work properly in this case, it has to be resistant to all kinds of security and attacks and things like that. So I'm not sure how you would do it, but I know you could do it. Either there's a bunch of people who run databases on top of IPFS, and people run queries on top of those databases, and they sign the block so that basically the files that they're putting in IPFS, so that nobody can alter them or pretend that it came from someone else.
Mm-hmm.
So we could have like the George and Eric, IPFS, database or Google search engine or whatever you want to call it. And
Sure.
you could build on top and sign this index, and people would query it because they could read it, but they would not be able to modify it. So you could do things like that, and then that index would be replicated everywhere and so on, because people would be querying it from everywhere. So
yeah, one of the practical limitations of having an index like that is that most people wouldn't be able to host the whole thing. So one of the other interesting aspects of IPFS is that it allows for users to hold partial contents of a data, which is also called sharding. And they also have something called versioning. So you can modify a file and then add a modification on top of it, and you can just host the modifier. Right. Yeah.
So actually, I work on distributed systems all day, and we do the sharding with consistent hashing. But here, I think the model would be actually might be very similar. To tell you the truth, I wouldn't be surprised.
Sure.
It might be very similar. Except you would need to have multiple replicas. I think most of sharding techniques right now are actually, that's not true. There's ways to do it. I know RYAC uses a hash ring. Which actually could probably be adapted to something like that. Idea could be adapted to run on top of IPFS pretty easily, and then you'd have a full database with CRDTs and all that, resistance to partitioning and all the fancy stuff.
Right. But I mean, what we're talking about, not only is it beneficial for bringing content to 800 million people, right? It's also incredibly disruptive, because what we're saying is that we could create an alternative to Google, which is completely open source.
Well, I've been saying it for a long time. The future,
proprietary algorithm.
The future is a peer-to-peer network.
Of course.
It doesn't make sense for companies to have all these servers. Everybody wants to do away with hardware. And all of this stuff can run on just the consumer's hardware. There's no reason for us to have servers that we access over slow links, and it would make a lot more sense that there'd be fibers connected in our neighborhoods, and I would just download from my neighbor at like 10 gigabits, and with 50 microsecond latency and whatever. That's basically the future. And the future is not to put, LA or some other place, or Virginia or wherever you want. It doesn't make sense. That model is dead, I think.
Well, it's Web 2.0, and it kind of made sense when they built.
It's dead in my mind. I mean, if you care about the future, that's not where to look.
Right. Of course.
I mean, people are still dealing with the cloud, and they're still, adjusting to that. And unfortunately, I think we're a little bit too early in our time for this, because, we're not too early in the sense that a lot of tech is going to come out now, but this stuff is going to become mainstream maybe in 20 or 30 years. And I really believe that's how long it's going to take, because before developers realize that, first of all, we're not even doing the cloud right. And when we finally do the cloud right, I think that's going to take at least another 10 to 20 years.
Mm-hmm.
And then when we realize, that peer-to-peer is actually really easy and we're already doing it in the cloud, well, we'll just say, why am I buying a server?
Right.
That's the end of the cloud.
Mm-hmm.
I
Well,
mean,
one of the major limitations is that right now nobody seems to see any obvious business model for completely decentralized peer-to-peer with no central infrastructure and no proprietary service in the middle, right?
well, one obvious use case for it is just low latency. Like everybody always talks about throughput,
Mm-hmm.
right? But latency matters too.
Yeah.
Latency can really improve your user experience.
Mm-hmm.
One of the things that makes Google great is they have servers everywhere. They have like locally distributed, like they distribute servers all over the place,
Mm-hmm.
so that when you're accessing Google, Google's not one place; it's a bunch of places.
Mm-hmm.
And so the DNS is globally distributed, so that you go to your local servers, your local data center.
Mm-hmm.
That's exactly what IPFS would be, but for the entire internet.
Right.
So that fast load page that you get with Google, I mean, it's optimized in other ways as well. You could get for everything. I mean, it would just be so instantaneous, very clean, very fast. We'd have to fix the browser, but that's another fight
Right.
that I don't want to get into right now.
One other obvious business model that I see right off the bat is if you linked a cryptocurrency to the IPFS network, and I think that Protocol Labs, which is building IPFS, is actually working on something called Filecoin.
Yeah, I'm aware of that. Yeah.
Yeah, but
It's just an app.
Right. Their model is essentially to kind of pay users to host content. So basically, they're trying to make IPFS into a cheaper data store. But I kind of see an opposite use case being far more compelling, where instead of paying to host your content, you're actually paying users, right, with a reward from the some kind of Filecoin or Bitcoin blockchain. For a currency that's specifically linked to IPFS, you could pay users a reward for sharing content that becomes popular on the IPFS network. So you could pay users essentially, let's say that you write a piece of code.
Yeah, and actually, all these things, they don't have to be attached together. I've realized with time that IPFS is just a file system.
Mm-hmm.
Filecoin is I don't get the idea of I guess it's a way of paying for storage.
Yes.
So it's kind of like the S3 of the S3 is a data storage service that Amazon offers in the cloud.
Right.
So it's kind of like the S3 of the peer-to-peer world. That's what they're trying to build.
Right. But I feel like if you gave for example, the community of open source developers and YouTube content creators an alternative, right? Where if like, let's say, for example, in the case of a developer, if you write an update to an app on this decentralized network, and your update propagates the network, and many people replicate your file that you created.
Yeah.
Right? Based on the number of replications across the network, that developer could receive a reward for contributing that file. And a YouTube creator could also be given a reward from the blockchain based on, again, how many replications of their video they get across the IPFS network. So, and again, there's all different kinds.
As long as you have as long as you have a way, some kind of Byzantine view of the network, where you're going to be attacked or cheated.
Of course.
Yeah, so you'd have to resolve that part, which is not easy, but maybe doable. I don't know.
Well, again, I get the feeling that, I mean, I've watched Juan Bennett's kind of YouTube videos, and I've watched some interviews with him at Y Combinator and whatnot, and he's definitely working on solving most of those issues. Him and his team at Protocol Labs, but again,
Yeah, but that
even
you have to also be
if
careful. There
that-
might not be a solution to that issue, or maybe there is one. I don't know. Some
but
things don't have solutions, though. Maybe there's a compromise that can be made or something like that. But maybe there's no like. It's a bit like the CAP theorem. You can have availability, partition tolerance, or consistency, but not all three. You have to pick two.
right,
And then if you do a lot of once you've admitted that and realized what the possibilities are, you actually discover that you can have like 2.7 out of the three. You
right.
can have most of the third one, but not quite the whole way.
Right. But still, I mean, even if you're getting 80% of the reward that you deserve for sharing your content, right? Assuming that there's going to be bad actors, but that there's going to be good enough verification methods. Let's say a bad actor takes your content or your code and modifies it slightly and then reshares it, right? Your content was still on the network first, and you still had a first mover advantage. So
Right.
you're not, even with bad actors, you're not completely disincentivizing developers and content creators from sharing valuable files with the network, right? You can still get 80% of the reward to the right people, which is better than
Yeah,
nothing.
but George, like think of it this way: IPv4 is maybe the way to do this, but the problem is that IPv4 is about to disappear.
Mm-hmm.
Okay.
Why is I for the way
Well,
to do this?
about to, what I mean by that is like in the next 15 years or so, I think IPv6 is going to be the dominant player.
Okay, but
Um,
why is
I know a lot
IPv4?
of people have been saying that for 20 years, but really this time it will because we're just out of IPs,
Right.
and we can find creative ways of reusing them and stuff, but it's just getting kind of ridiculous at this point.
Mhm.
So it's just better to use IPv6, and actually it works very well, and a lot of sites already support it. And the adoption rate is going up by about 5 to 6%. Now, why is this relevant? Well, it's relevant because with IPv4, you could say, well, I'll only recognize this as one download if it comes from one IP. Even if there's 1,000 machines behind this thing,
Mm-hmm.
or one, I just count it as one. But and then you have a fairly, because IPv4 addresses are expensive, to mount an attack is an expensive thing, and so it's the same as buying, like as being legit, pretty much. So
Mm-hmm.
it's not that interesting. But with IPv6, with the address space being 128 bits, and everybody getting a /64, you really don't know where the networks start and end at all. There's just no knowledge of that, and so the problem is you can't tell whether this is just one computer or 500 computers or 1,000. In fact, one of the default operating modes of IPv6 is to create ad hoc addresses in those ranges,
Mm-hmm.
each connection, so that
Right.
you hide the source, so that they can't connect back. It's a security measure,
Right.
kind of like a capability, um, which is quite good. I like that feature, but the problem with that is that it won't help you in identifying how many copies are there out there. So, like, I can have a server that pretends to be like literally trillions of IPs that
Mm-hmm.
will say, "Yeah, I have the content, and here it is," and it's only one machine.
Right.
Problem is, how can you tell that this is one guy and not another guy? You'd have to ask him to do some computation, but there's no incentive for him to do that. You know what I mean? To prove his
One way
content.
one way around that, I mean, again, since we're talking about using something like a distributed hash table where the users are essentially primarily identifying themselves through a hash rather than through a dynamic IP, because even with IPv6, the IP addresses are constantly in flux, right? So of the peer-to-peer users rather than people operating data centers on static IPs.
I mean,
So
one way you could do it is let's say you had a cryptocurrency and you had money. No, it wouldn't work either. Well, actually, it would work a little bit. So I'll still mention it. Let's say I have an account with money in it, like $10 or something. Okay, it doesn't really matter. I could use that account's key to sign some content. And that doesn't pay any money. It just says that, hey, I'm the owner of actual money on this network. And so I have sort of an identity.
Right.
My identity is tied to the fact that I own this. You know what I mean?
Sort of like a proof of stake model.
Yeah. And you wouldn't necessarily split all your money into thousands of accounts because you'd lose money on transactions and stuff like that. So,
of course, yeah. So linking your wallet to your content to a certain extent makes a lot of sense, right? So again, your hash that you're using to link yourself to your content and to other users over this distributed hash table would.
Yeah, but there's flaws in that. There's a lot of flaws. Like, for example, I could in advance create 1 million accounts, with very tiny fractions of amounts of money. Maybe I have to say that it has to be a certain amount of money for you to sign it. And then, then I produce a ton of content and just have all of those addresses always sign them over and over again. That's a way to cheat the system. And then how do you reward people who've really produced real content versus people who haven't? It's still a hard, you have to admit, that's kind of a hard thing to do. I don't see a clean, easy way to do it.
Well, one way would be to verify, like to check the integrity of the content itself, right? So in order to get paid, you'd be essentially getting paid based on the number of replications that your file has over the network. So even if you're posting your own file 1,000 times, that costs you storage.
Yeah. No, what I'm saying, George, is that you can't say how many copies there are. You have no way of knowing. You could have one guy pretending to have 1 million copies. And in fact, that's dangerous. Because if you're doing charting over that, some guy could pretend to be someone he's not, and then basically take all the segments of a chart and destroy the data. You know what I mean? Like, it's not... you have to think of this from an attacker's point of view for this to work, because it doesn't mean there's not a solution to this problem, or there's not a compromise or some other system that achieves the same goal. Like, I'm sure your goal of paying people for content online is unachievable.
Oh, I'm sure that it is.
On a distributed system.
Yeah.
A peer-to-peer one. So I'm sure that's achievable. I mean, it could be as simple as, I'm not going to give you the content unless you pay for it. But then, like, you could have a key. But then the problem is somebody else might give him the key or whatever. Yeah, so we're back to, like, old, shitty models that don't really work.
Right.
Yeah. So maybe it's based on only, goodwill, but then that's not... If there's a monetary reward for goodwill, then there's going to be competition to cheat that. So
well, I'm sure there's heuristics. I'm sure there's heuristics that you can use, again, to evaluate whether a node on the network is a good actor, a neutral actor, or a bad actor, right? Like, based on how much money they have in their wallet, based on how old the node is, how long it's been on the network, what is its uptime consistency. There's a bunch of things a bunch of metadata that you can actually take into account to measure whether a specific actor on the network is malevolent or neutral or benevolent, right? You can see that.
But that's also assuming that you can detect it. So you have to have a mechanism for knowing the person's cheating, right? Like, you can't... Like, if I have a host that pretends to be 10 trillion different machines, like, you have to be able to detect that I'm actually cheating. Like, I'm still holding that content. You think, there's 1 trillion copies of this thing, but there isn't. There's just one copy of this thing on one machine, but I can't tell them apart. They all They all behave the same. They all answer the protocol. They all pretend to be, when I access it from this IP, it pretends to be this, and when I access from this other IP, it pretends to be that other machine.
Mm-hmm.
And nothing is telling you that these are two different machines, actually.
Right.
So, yeah, so maybe you could do it by challenge, where you ask it to do some computation. But then again, the problem here again is the synergy. There is no reason for those hosts to compute something for you.
Mm-hmm.
You can't rely.
But again, you can see.
On goodwill. Yeah.
You can see, for example, if you're using something like a distributed hash table, which is a hash that you yourself chose and then put in the table that everyone is sharing, right? So you can see when that hash was added to the network, and you can see how that hash behaves, and other users can report.
The hash doesn't do anything. It's just a hash of some content, and then there's some very complex resolution mechanism to find it on the network.
Mm-hmm.
Maybe it's simple, maybe it's complex. I would assume it might be complex in this case, but then that really doesn't tell you anything about how many copies there are, or if people are cheating or making fake replicas of it, and so on.
No, but what I mean is, for example, right, if we're using an addressing system based on a distributed hash table, right, where
Content address.
Yeah, content addressing based on something like each node has one hash on the network, and then each hash simultaneously can broadcast one IP address, right? Obviously, one hash cannot be. So that's what a distributed hash table does in BitTorrent, for example, is just an alternative to a DNS system. Instead of having a domain name pointing to an IP address, you have a static hash pointing to a dynamic IP address. And whenever your dynamic IP address changes, you can rebroadcast your new IP address to
this is a little bit
hash network, right? So you can tell how old one node is based on how old its hash is on the distributed hash table, and you can also see other metadata, right, based on how it behaves on the network. So you can have all of the other nodes evaluate all of the other nodes.
Yeah, but George, even timing in a distributed system is very hard to do, because time doesn't actually advance at the same rate everywhere. And in fact, you need a trustworthy source of time. Like if you want to know that this event happened before this other event, that's not an easy challenge. That's actually quite hard to do. It's not as simple as it seems. You might rely on trust to get that working.
Right, so maybe there's some modification of a distributed hash table that would be using like blockchain.
The blockchain is the way around that. Mm-hmm. Like the blockchain, like you have what's a vector clock basically, right?
Yeah.
The blockchain the block number is a vector clock. Okay, mm-hmm. It's a thing that's incrementing in time. Right. Now you can't trust it immediately. It takes about an hour to converge, because before that it's not secure.
Right.
It might still change. An hour is kind of long, but that's kind of like the rule of thumb here. It's about an hour.
Try to keep your face in the center of the frame, please. Yeah, perfect.
Yeah. So. Yeah, I don't know. Yeah, I like the idea. I just don't see how to make it work easily. Like I know that you can use a blockchain to get that timing.
Yes.
That timing only gives you it's this
That's
position.
The entire point of blockchains is essentially to solve the double spend problem, right? To see what happened before, what transaction happened before something else. So this this problem is completely solved by putting a distributed hash table in a block.
I'm not convinced that the hash, knowing when the hash appeared. So it's useful to establish who's the author or something like that.
The first hash that shared the content.
Yeah, so if I create some video and I put it in, I put the signature of it into the blockchain at some time, and then
Yeah.
somebody shares it later on, someone else,
Yeah.
they can't prove that they own it because I have an earlier proof that I
Right.
own.
Exactly.
So that might be, yeah, that's useful for that. But then again, those things rely entirely on, like, you can't rely on an algorithm to be basically, like, let's take the example of a video. If I change a single byte in that video, it's a new binary,
Mm-hmm.
right? So to be able to tell that that video is the same as some other video, you need to do a lot of analysis on that video. Like, you need to do some, basically run some machine learning stuff on it.
Sure. Sure. Which is possible, right? It's possible to
Sure.
do.
Yeah, it is, but it's expensive. It's not. These are not cheap operations. This is not something like your cell phone's going to do. This is something that where your CPU's, your GPU is going to be running at 200 watts
Mm-hmm.
for 40 minutes to test one video or something like that. Maybe I'm exaggerating a bit here, but I don't think it's unrealistic to think that. I think comparing video and all that might be. Although YouTube does it fairly well, so
No, but
maybe.
let's look at it this way. Let's say that you have, for example, in the use case of a YouTube channel, right? So your username on YouTube can be linked to your hash. And then every time you publish a new video, your subscribers can just be notified that you published a new video. So you're still getting the first mover advantage on
Oh yeah,
sharing content.
yeah. I think in practicality might not matter much.
Yeah. Like
I,
even if there's bad actors, they're copying content and then claiming it as their own, right?
yeah.
Or even if there's people that are
Actually,
taking,
that happens on YouTube. Actually, people will
yeah,
take something good and will
yeah,
just share it to get a lot of views,
yeah,
and sometimes that works surprisingly. Some YouTuber takes down their video and then they put it on, and suddenly, they're making money off of it. So
right.
it's yeah. So
Still, that's, I mean, most, like most,
no, but that should just be part of the rules of the game. Like, some people could cheat or whatever, and it's just if there's no cost to the video, okay, I know where we're going with this. We're going to basically have a currency which is issued in order to pay for the content,
yes,
right? This is basically where we're going with this. So I guess an issue we should even talk about before we talk about details of this is it viable to issue currency for content? Would that be a viable currency?
content or even code. Yeah,
Yeah. I
why
mean,
not?
would it be even viable? I mean, could you do that and have the currency not lose its value? Like, what is the incentive for people to own this currency?
Well, it's scarce, I guess, right? Like,
Yeah.
for
So it's just
example,
artificial scarcity. Yeah, okay. It's artificial scarcity. So but then, okay, so it's issued at some constant rate. We determine the proportions by viewership or something like that.
yeah,
And that's how we do that. We secure it with some kind of proof of stake thing that doesn't take a lot of power or
not
some
necessarily viewership, but replication, right? So
yeah.
for
Like,
example,
let's just keep the video one as an example for now, and
yeah,
then we can consider other ones.
sure.
The audio would be very easy to extend from there, and then maybe even file sharing as
And code, like
an
having an
application,
open
or
source Git
maybe even
repository.
services.
Yeah,
Maybe even services that run on top of IPFS or something like that. So
absolutely.
yeah, maybe there's huge potential there. Actually, maybe I should buy. Is Filecoin an actual blockchain that's working right now, or?
I'm not 100% sure. I don't even know, like I haven't seen any new content on YouTube from Protocol Labs recently. So,
Yeah,
I like
the big
my biggest fear is that, they ran out of money and that, we're heading into this crypto winter. Well, we're already in another crypto winter, but My biggest fear is that Protocol Labs runs out of funding, because this is very promising technology, again, for huge markets like China, where there's a massive potential to offer censorship-resistant content distribution, right? So that's...
Yeah. No, I get it.
It just...
What's the,
I feel like...
Did you look at DTube? DTube's running on top of IPFS.
Well, no, I mean, when I looked at it, it was a website that you go to through a browser, and you had to sign up a user account. It
No,
didn't...
no. Today, I did it today because
Okay.
we talked about it. Yeah. So today I downloaded, I cloned it off GitHub, which is weird because it shouldn't be on GitHub. I mean, they could just host it on the IPFS itself. But then
Right.
again, yeah, chicken egg problem, whatever. Okay, so
You have to strap your network somewhere.
yeah, exactly. So okay, so I got it. I compiled it, had a few problems because it's still in the pretty ghetto. You have to be a developer kind of run this.
Yeah.
Anyway, I fixed it, got it working, and it was working straight off IPFS, hosted off localhost.
Okay.
So yeah, so it can be done. So the idea would be basically that IPFS. I don't know if the implementation of DTube is very good there, but IPFS could be just distributing the content, and your browser would be running the code. There'd be some kind of browser that would have the capabilities of, running that code.
Yeah, so you'd have to have an IPFS browser.
Yeah, I'm guessing maybe something more. I don't know if it would have to be more powerful than the current browser, but IPFS would have to host a local web server. Ideally, it would be best if they would just, tie a browser and extend it.
Right.
Yeah, because it's
I heard
just
rumors
weird.
that
Referring to local hosts and all that, it's just that's not the way to do it.
I heard rumors that Firefox was actually working on that at some point, but I don't know if they dropped it or not. Again, we're in a crypto winter. I don't know if any of these projects are still funded. I hope they are, but...
Yeah, well, actually, the stock market's dropping like a rock right now. It
Yeah.
dropped 3% just today. Like wow.
Yeah, Apple dropped like 10% already. It's ridiculous.
Yeah, but their valuation was crazy, and so is Amazon's. Like it's complete nonsense. $1 trillion. What are you talking about? So, you know what I mean? It doesn't make any sense.
Well,
Like,
with Amazon, it really doesn't make any sense, because if you compare their market cap to their earnings, it's like 30 or 50 times, something ridiculous, some ridiculous multiple.
the P ratio,
Yeah, it's crazy. So, but with Apple, it's like it's not unreasonable.
yeah.
But whatever. I mean, whatever.
Well, yeah, Apple is a luxury product that's in demand. So yeah, no, I see it. I see where people think Amazon's the future. A lot of people are shopping on Amazon, and their cloud side of the business is huge, like really enormous.
Yeah.
However, I think the thing after cloud is peer-to-peer. There's just not going to be a cloud in the end.
Yeah, I agree.
I think that's. I mean, developers who are in crypto and stuff, they just see it. It's written on the wall. Same thing with politics. Politics are the next big thing for crypto.
Yeah.
That's going to be the biggest revolution in politics in 5,000 years. I don't know, maybe more.
Well, it's going to be a huge upgrade to democracy. I mean, once you can have voting on a blockchain.
Yeah. Well, getting to that, I'm not even. You know my position on this. So I used to, like everybody else, actually, really believe in the idea of democracy until I realized that what we have today is more like a popularity contest.
Mm-hmm.
And even if we did have a direct democracy, which means everybody decides, I don't think that is a good model either, because I don't think people actually care to do the work that's required to make good decisions. And I think it's a sad reality, but I think that's the reality.
I don't know if that's 100% accurate. I mean, in a lot of countries, democracy does work very well. At a certain scale, it does work very well. I mean, we can't just look at the US.
I don't know if it works very well. I wouldn't say it works very well. I would say it works better than some other things. It's not the worst system.
No, but I mean, again, whenever people talk about...
I'm not saying communism is good, right? Like, obviously not.
Obviously, but what I mean is,
I don't believe in that at all. But
we can't necessarily look at the U.S. system. We can't necessarily look at the U.S. system, which is basically completely run by special interests, right? And we can't really call that a democracy. Like, that is the biggest and most famous democracy.
It is a very good popularity contest, though, you have to admit, and reality show.
But there are other democracies in other countries that work much better. Again, just if you look at the actual results and the outcomes of their societies, right, in terms of wealth generation, in terms of UN happiness index, in terms of life expectancy and everything else, you know, there are systems in countries like Norway and Sweden and Finland.
I'm not buying it, but yeah,
Well, no, just based on GDP per capita and median income, right? These are some of the wealthiest countries on earth.
Yeah, but they're deferring their wealth, and they're oil rich, so it's not. Yeah, I'm not.
The U.S. is not mineral deficient. I mean, we can't say that the U.S. is a mineral is a mineral poor country.
You can't compare the U.S. to anything really, because they have a printing press with no backing.
Exactly.
Which is the world reserve currency. So that doesn't, you can't really compare that to anything at all.
No, but what I mean is like, just generally speaking, there are systems that are democratic that work better than any other system at producing wealth and happiness currently, right? So
I think honestly, I think a meritocracy with a democratic filter is the most popular. That is the best system I could come up with on my own. Is a system where people are prove themselves. I came up with a system with a crypto where you could do this, where you create a crypto that's amendable. And what you do is you take people's changes into your crypto. That's why it's amendable, so that you can take people's changes. And in exchange, you give away some of your merit.
Yeah.
Right? You give some merit. So you're recognized by somebody who has merit. And the system itself has to be recognized by outside parties as having merit, because people buy into it.
Right.
So the merit is, there's a synergy between all the components there. So people earn merit, and you give away merit, and every time you give away merit, you're making a calculation. Is this feature worth more than the merit I'm giving away? And if I don't give this merit away and get this feature, will this create a new, basically, competitor to my crypto, diluting my value? Right. So both parties in that negotiation have a strong negotiating position, depending on what it is they're trading. So if it's a powerful feature, then you have to give away a lot of merit, and if it's a small feature, then you don't have to. You know what I mean? It works pretty nicely. Sure. And then what you have is a filter. So the filter is, whenever you have a change like that, the meritocracy exchange merit for the feature, because they believe that will make their asset more valuable. Right? They have money basically in this currency. They're paid a salary through the blockchain. This meritocracy. Now, in order for those changes to take effect, there is a filter that goes across the entire population of people who have it. Basically, if it was more like a political system, it would be per identity, and if it was just a currency where you're just voting for stuff like that, like more like an organization, then it would be based on how much money you have. You get to say yes or no to each thing. So the meritocracy gets to put forward ideas, and you get to say yes or no, and that's it. So I think that system would be very good, because there's people who are fully focused, fully engaged in producing ideas and changes, and people still have to be okay with it. You know what I mean? You can't just push things onto people. Right. have a control from the people who are at the bottom.
Sure.
You know,
But I mean, again, I wonder if that problem couldn't be streamlined a little bit by, if we can solve the problem of accurately measuring how many nodes are replicating a given file. If we can solve that problem correctly, then basically, you could propagate a file that would essentially represent a software update to your version of the direct democracy. And if users choose to run it because they feel like it benefits them, that's the yes or no voting mechanism. So again, a lot of things I think are kind of contingent on a currency that incentivizes people to create files that propagate, that replicate over a large number of nodes on a network, right? They would receive money.
I'm just kidding.
What's that?
Like a virus.
Exactly like a virus. Yeah, why not? Hey, if the virus survives, it's a good virus. Right?
Yeah.
Like it's a fitness function.
Sure. Okay. So I wouldn't get too tied up with this. Yeah, I don't know. There may be a way to make it work where, in order, like I came up with, remember I had an idea a long time ago about an internet where there'd be payments for packets.
Yeah.
You would establish a route, and you'd kind of do a bit like onion routing, where each layer would pay each router along the way.
Yeah.
Maybe you could only be paid by the next router down the line. So your incentive to pass the packet would be like, you would see that guy has a valid payment for you, which could only be unlocked by the next guy, right? You have to send the packet to the next guy to get the payment.
Sure.
So you would have basically a mesh network like this, or it doesn't have to be a mesh network, but you'd have a network built like this, and where every next person would need to pay the previous person, and so on. And so that would be the incentive.
Yeah.
Maybe you could have a system like that in order to host the content. Like, if you want to get the content, you have to pay like a very small sum, like something like 5 cents, a penny, or I don't know what it is, but some very small sum. And that person, and putting a cost on it means that, the guy who's hosting it wants to get his payment for the content producer before he'll give you the content. You know what I mean? So maybe there's a mechanism like that where
that doesn't necessarily encourage the spreading of information, right? That we want more information to spread.
Oh, it does. It does because, well, if you spend 20 cents a day on content, I mean, I wouldn't care at all. I mean, I spend more probably than that on content right now with Netflix and all those things.
Right, but the person paying,
and that cost is variable anyway. You can make it whatever you want. It's not, and that could be used in augmenting the payment to the producer, like the owner of the content. So, for example, if everybody paid that guy for his content $20, then maybe the blockchain issues $200. Like it could be like that for that guy. But then there's a risk. The risk is that it could just be an amplifier, so you could still cheat it. So yeah, maybe it has to be less than the amount like it could maybe supply, like it could maybe contribute 40% by the blockchain. So maybe you collect 60% from your audience and get 40% extra from it. That way you can't cheat it, because it would cost you more than what you would get.
Yeah, I don't know. I mean, I just
to get 40 and then you lost, right?
Yeah, but I mean, in practice, one of the issues with that is, I mean, whenever you have people holding a cryptocurrency that's going up in value, there's usually an incentive to hoard, right? So if people would have to be paying even micro payments for content, there would be some reluctance, right?
Well, this thing would not have it would not be like Bitcoin where there'd be a maximum cap. It would just have a rate of issuance. So it would inflate forever.
Which would be constant, yeah.
So which may be a bad thing. Maybe it won't make it popular, but maybe if the content is popular, then there'll still be demand for it. You know what I mean? So I don't know. It could work.
But I mean, in order for the network, in order for a popular file to propagate the network, you want to incentivize people to do two things. You want to incentivize people to create the file, and you want to incentivize people to share the file, right? So you create the file, and then I think it's a cool file, so then I host the file.
So when I go and ask for the file, so when I ask for the file on the network, I pay the people who are hosting it to me. So that's honest, right? Because they actually have to spend network bandwidth to send it to me.
Right.
And paying for it will guarantee some quality of service. Right? Where I'm paying something and I can pay more if I want faster, or, like we could have a system like that. May not be a popular idea, but it might actually work really well in practice, especially if they're really small amounts of money we're talking about here. And in order for this guy to be paid, he has to verify that you've also paid the content owner. So he won't host the file to you until you've proven that you've paid the owner. So you have a proof in the blockchain that says that you paid the owner. You have or in a Lightning ledger, and then you have a proof that and then you pay him. So once he can't be paid by, you could have a payment where the payment only works if the owner receives the payment.
Yeah.
You can have the blockchain enforce this, or the owner enforce this, or you could have some way of enforcing this. I'm pretty confident you could do that.
And also that completely solves a lot of problems if I come to think of it, because once you actually have money flowing from users, right? There's a total disincentive to be sending money to random users for data that you don't want, right?
Yeah.
So if you're making micro payments to content contributors and to hosters of popular content, then another thing that that data can also be used to measure the validity and the whether or not each node in the network is a good or a bad actor. That's just more metadata that the blockchain can use to issue rewards to hosts and to content creators.
Yeah, especially stable ones. So actually, not just that. If I download so I've paid the owner. Now the host will now will now serve me the video. Now all of this has to happen pretty quickly, so it might have to be like lightning, so very fast, like millisecond.
Yep.
Then I negotiate with the guy who's hosting it, and
So
now I become a host, and I become a host,
right?
Because I have data, and I collect money for the owner,
right?
So I can get maybe some of my money back for hosting it. So if I'm the first one to see this video, and there's a lot, like this is a viral video or whatever, I might actually make more money than it cost me to view it.
Exactly. So there's an incentive there.
Yeah. So
anyway, it's also kind of a filter on incentive to host.
There's also incentive to host contents for long periods of time. So for example, if I have several 20 terabyte hard drives and I'm the only one hosting this content, then every time somebody wants one of these things, I can charge a little bit more because it's rarer, right?
Right.
So it could be based on supply demand kind of mechanics. Of course, if I charge too much, so it also forces me to put a good price on it that's not excessive and not too low, because I want to maximize my profit.
Sure.
Yeah. So.
Which makes a lot of sense. So actually, making micro payment. And when you talk about Lightning, you mean Lightning Network, right? So that's
like off blockchain ledgers, which are just used to compress the transactions.
Right. So basically, one of the major limitations of any cryptocurrency is the scaling issue, because For example, Bitcoin can only handle 7 transactions per second. And what the Lightning Network does is it enables payment channels that allow people to have like multi-signature kind of wallets where they put amounts of money into one wallet, and then they individually off the main blockchain kind of determine they have transactions between each other, which can happen very, very quickly because it's directly peer-to-peer. It doesn't have to go through a blockchain with a 10-minute confirmation period or anything like that.
They can basically create transactions which can be put on the blockchain to resolve any ledger that they have privately.
Yes.
And the idea is to, every time that you do a trade here, is to collapse all the history into a few transactions.
Yep.
That basically sum up all the totals.
Mm-hmm.
And only when there's a disagreement do you publish that on a blockchain.
Right.
And then that's made, it's set in stone at that point.
Right.
And of course, you avoid all the transaction fees.
Lightning Network would actually enable these micro or even nano transactions of cryptocurrency in real time in exchange for individual packets over IPFS, paying making nano payments for individual packets, or very, very small payments for individual packets serves a lot of functions. I mean, it's a filter for shit content, and it's again something that you can use to measure whether or not a node on the network is a good or a bad actor.
Yeah, actually, you can, because that person will receive a lot. If they produce a lot of value, they get a lot of value. As simple as that.
Yeah.
As simple as that.
Makes a lot of sense.
And there's a cost to it, so nobody has an incentive to cheat this because they'd lose money on the cheating.
Right.
Yeah, so it's it's strong.
Mm-hmm.
It's secure. Yeah.
Right.
So, yeah, that could be a workable thing. The size of this project scares me. Right, because you can imagine, building all this. You need a lot of money to be able to build.
The thing is, if it gets built, not only do
it just when. Yeah.
Yeah, but when it gets built,
mm-hmm.
Not only do we have basically completely censorship-resistant content distribution, right? Which addresses a lot of human rights issues in a lot.
We also have a new political system.
Yeah.
At the same time, because why wouldn't we run it on top of that? We have a new monetary system.
And we can also completely disrupt the current tech industry, right? Like if you have a decentralized index of content which is sharded, and you're searching that index with machine learning algorithms that are running on your machine rather than in Google's server, well, now you're being served search results that are optimized for you rather than for Google's advertising business. And you've just completely disintermediated Google, right? So this is an incredibly disruptive technology.
Yeah.
That would democratize information. That would basically, I think it's incredibly powerful. But right off the bat, there's a huge. We have to really. I really need to drive home the point that there's a huge market for this. Even though most people, are mostly satisfied with the internet as it is, most users don't understand the potential of this technology.
Yeah.
But for investors that might watch this interview, I really want to drive home the point that there's 800 billion internet users in China. There's, I don't know how many internet users in Saudi Arabia and Iran and all these other countries that censor the internet and block everything. Right, and then track metadata and all of these things.
Yeah, but I mean, even if you ignore that, even if you're just on the investor side, you're not trying to be competitive in China or whatever, this is going to disintermediate everything here. Forget about even China. It's going to change the political systems here, even.
Well, it's completely game-changing technology. I agree. But as
The future of humanity is going to look something like that.
Mhm.
Like when we go multiplanetary, there'll be something like that already in place. I think
Mhm.
by that
Yeah.
by that time. So, and I don't think we're talking that long before some humans step on Mars, or or we start building, basically space stations where people actually live. We're talking, maybe a couple hundred years at most.
Yeah.
Yeah.
In
For
order to
this
get there,
technology, that's why I'm saying this technology will come in first, because um, that's not a couple hundred years away. No, no way. This is 50 years at the very most,
Mhm.
and 20 with an accelerated effort.
Yeah.
Yeah. So, yeah, it's going to happen, and it might happen even sooner than we expect. Everybody's thinking about it. Everybody's thinking about it. Everybody's talking about it.
No, but
And
it's weird because I talked to
tons of
some
money
people
flowing
about
into it.
it. I talked to a lot of people in the blockchain industry, and the blockchain community on LinkedIn and on my in my WeChat groups that I'm in, and it's not immediately obvious to everyone. Like everyone's kind of focused on Bitcoin and disrupting the fintech industry, and
Yeah,
that
this is
and
small. I'm talking about disrupting human civilization. Like that's what we're
yeah,
talking about here.
it's far more it goes much further than that. I mean, and that's what nobody seems to kind of really fully appreciate. This is about more than just speculating on the price of Bitcoin.
Yeah,
This,
yeah,
right? Like people who come in at the ground level on this technology should understand that this has radical implications and
yeah,
ramifications on human civilization, and that if you're an early adopter, you stand to benefit greatly if you take the long view, right?
yeah.
If you're just trying to figure out
Oh yeah,
whether
of
you
course.
should be long and short on Bitcoin because
Yeah,
of
forget.
the price
You can
speculation.
make a lot of money that way, but that's not the future. The
No,
only way to predict the future is to invent it, and the future is not to speculate on Bitcoin.
right,
There is no future in that. There might be, a few waves to ride, to make a little bit of money, but that's not a goal. That's
right.
not, you know, that's just silliness. However, it is necessary, I think, for the ecosystem to develop itself a bit.
Hmm.
But what I'm worried about with that is that because people are so short-sighted,
Hmm.
they might actually converge on something that is short-sighted and take longer for the disruption to happen
Yeah,
by distracting people with all kinds of irrelevant stuff.
right.
You just have to look at all those altcoins on the last bubble. Complete, just a bunch of crap that didn't make sense.
Yeah, so again, I feel like the point that I want to drive home to anyone who might be watching this is that being long on this technology and understanding, if you understand the potential ramifications that this technology could have, the potential disruption that this could have on democracy, on Web 2.0 companies like Google, like Amazon, like Facebook, like any cloud service provider. If you understand how this could completely disrupt the current tech industry and how it could completely disrupt fintech and how it could completely disrupt democracy, you know, it's just this is more than just Bitcoin speculation. There's also massive human rights advantages, right? So for example, Article 12 of the Universal Declaration of Human Rights is about people having the right to privacy in their home, in their family, and in their correspondence. And as we learned in 2013 with the Edward Snowden revelations, um, basically nobody on planet Earth, including American citizens, have any kind of guarantee of privacy in their home, in their family, and certainly not in their electronic correspondence, right?
No,
And
obviously not. Which
right.
is really, really silly if you think about it.
It's unfortunate. It's unfortunate, and it's a serious issue. And then the other,
And
just
it's
a basic.
due to centralization. A lot of this is because we put our data in servers.
Yep,
Because
absolutely. It's all about something.
they go to the to the company and they say, hey, give me all your data, but that data shouldn't even be there.
I agree.
Right? It should not be readable. It should not be decryptable. You should have the only key, and they shouldn't have all of it. Like it should just be a bunch of people who have it all over the place with replicas, so that you don't lose your data, and you pay a certain amount to store it, a very small amount, but something.
So not only does decentralization help people with the basic human right of privacy, but it also helps people with the basic human right of being able to speak freely and access information freely across any border, right?
Yeah.
Physical or artificial, right? So in terms of free speech applications, decentralized networks like IPFS and cryptocurrencies are immeasurably valuable, and also in terms of privacy benefits.
I can predict there's going to be some great chasm to cross here. So here's a prediction I'm making. You know how Alan Kay says the only way to predict the future is to invent it?
Yeah.
Well, there's going to be a great chasm, a bit like what happened with Tor. Tor is a great tool for for basically anonymity and privacy. So
assuming you trust your exit nodes.
The problem is the first adopters are going to be people doing illegal stuff and morally reprehensible stuff like child porn and all this kind of stuff.
I don't really agree with that. I don't really agree with that because, for example, what we know, even recently, there were some revelations about HSBC Bank and some very, very distasteful behavior in Mexico, where they were deliberately and knowingly and on purpose laundering money from Mexican drug cartels. And like Bitcoin was invented in 2009. I feel like it's pretty obvious that money laundering existed way before 2009.
Oh, no, that's not what I'm saying.
Yeah.
What I'm saying is you're going to have a scenario like Tor, where the community is going to be very toxic at the beginning.
Like Silk Road, for example.
Yes. It's going to be very toxic and very hard to defend at the beginning. But if we can get some mainstream components in there, some things that people go to. The problem with Tor is there's no go-tos. There's, other than human rights and stuff, everything else is shady, right?
Well, yeah, you cut off just then.
Anything that's not to try to resist censorship is very shady in Tor. Like it was basically a giant.
If it's necessarily shady, like let's think about
it was
great talk.
Have you been on Tor?
Yes, I have. Yes.
Yeah. So you know what I'm talking about here. That like half the stuff on there is I'm saying half. I'm being really generous. Like 90% of the stuff on there is just illegal stuff and all kinds of craziness. Right. That's what I'm talking about. If we can create something like YouTube or something like that at the beginning, where people can share content easily, then that might, cross the chasm. There's going to be a chasm. Like that's what I'm explaining. The early adopters are going to be two types of people. There's going to be people like you and me who just, are interested in the technology, and then there's going to be people who have who want to make money with it, And then there's going to be criminals, and there's going to be people who want to hide their child porn and sell it, and there's going to be weird stuff. On there, and that's how it's going to be. It's just going to be like that, and until we have more mainstream audience joining into this, it's going to be a little bit shady, and that's going to represent a chasm to cross, where we're going to have to look legitimate at some point, but it won't be easy, and that's the chasm.
Yeah, but another thing that I want to point out, there was actually a really great YouTube video from Andreas Antonopoulos recently that I saw about black markets, and he makes a lot of very good points in that video where he says, like, for example, YouTube technically in many cities, in many markets, YouTube is not YouTube, Uber. Uber is a black market because the law says you have to take a taxi from a medallion driver, and that medallion costs $200,000, for example. And Uber comes in and offers a better service in many cases for a lot less money. So it's not necessarily true that black markets are immoral, right? It's necessarily true.
No, I agree with you. You're 100% right about that. But yeah, morality is not tied to legality. It's not. There's not a one-to-one correlation there. Obviously not. Otherwise, the law would never change, right?
Exactly.
So, yeah, obviously, you're right about that. And there's shades of morality anyway, and so it's not clear.
I agree that definitely there has to be.
I'm just saying there
benevolent
will be
applications. There has to be benevolent. I agree with you in what you're saying, that the chasm, in order to cross the chasm, developers have to build benevolent, application. It can't just be a marketplace for assassins and guns and drugs and prostitution and all this stuff. And
but it will, like, it's like anything else. It's like when people say, "Oh, we didn't do communism right. Let's do it right this time." There's no such thing. It's just a population of random people, and it will change, and it will settle into some kind of balance, equilibrium.
Yeah,
it's the same thing here. There will be at the beginning, it's going to settle in some kind of equilibrium, and as the population grows, it's going to become more and more legit. But at the beginning, it's not going to be.
Yeah,
I think at very early phase, it'll be very legit. Middle phase, there's going to be this huge chasm where there's all this illegal crap going on. And then at the end of it, it will either survive in its current forms or beat by some other system that's similar.
Yeah.
Or get through it and become mainstream.
Sure.
And I think that's but my prediction here is that there will be a huge chasm somewhere. It might take like 10 years or something to get through that.
Well, especially the incumbent interests are going to find whatever they can. If this starts encroaching on their power or their market share, right? Obviously, they're going to do whatever they can to say how bad it is and to make everybody think that.
Yeah, and it will be like that. People will be like, "Hey, look, it's just kind of what they said with Tor, right?"
Of course.
Yeah.
Of course.
So it's the same thing.
I don't necessarily disagree with you.
Yeah.
I
think it'll be better than Tor. I don't think the chasm will be as great as with Tor, because with this, at least you'll have money in the system. You'll have all kinds of things driving it.
Yeah.
With Tor, it really has just two. Like, there's not that many dimensions to this thing. Either you're producing.
And plus, here's what's fucked up. At least when I was in China, Tor was completely useless, right? It didn't work. In order to use Tor, you'd have to send an email to get bridges, and then it was complicated, and those bridges didn't necessarily work, and you had to do it a bunch of times. Tor worked really well when you were using a commercial VPN. So if you want to be secure in China, right, you have to understand that VPNs in China are ridiculous. They make no sense.
They're being cracked down on right now, no? Although there is a trick with SSH, by the way. SSH is -W flag. You can enable a tunnel over SSH, and blocking SSH is one hell of a task because almost all network equipment uses it to be configured. So they're going to have a really hard time blocking that one. But there's a way around it. That's what I would do it if I
No,
were
I know,
some.
but I mean, like, so the Ministry of Information Security or whatever it's called in China that actually censors the internet, right? They have potentially millions of employees working on censoring their internet and also working on, commenting on negative videos and flagging, content that they don't like and all this stuff. So when I look at VPNs, I approach it like, let's assume that all of these people were completely incompetent, which they're not. But let's imagine that that they didn't know what they were doing, right? How easy would it be for me, for example? I'm not that technical, right? How would I go about, just from me by myself, figuring out if I was working for the Chinese government trying to block VPNs? All I
Yeah,
would have to do is use any popular search engine and search for VPN. And then I would sign up. I would sign up for an
yeah,
account
making it hard.
with all of these VPN providers, and I would get all of the IP addresses of all of their servers, right? And
Yeah,
then
yeah.
and then I would, so there's no reason for these VPNs in China to be open other than some kind of bribery scheme where they're paying for access to the Chinese market, essentially. And there's been a lot of people who have observed that the encryption schemes that many of these VPN providers are using are not necessarily guaranteed to be secure, um, and that there's a lot of issues where basically using it, like, you have to assume that if you're using a VPN in mainland China, that you're probably not secure. And also another interesting thing, for example, when I used Astro or some other VPNs, they had these VPN apps that automatically configured your computer to route all traffic through their servers.
Mhm.
But these apps required my root password.
Yeah.
Okay, so
So
in order to install this app, I had to give this app basically master God mode over my Mac laptop. I had to turn on, and I don't know what they're doing with that root access. I just have to completely trust that this VPN provider is a good actor.
George, I have a solution that's very easy for anybody. By the way, if anybody's listening, I'm not advocating doing anything illegal,
Mhm. Yeah.
but a very easy way to get around all this stuff is just to use SSH. You get literally a shell anywhere on
Hmm.
any SSH machine anywhere in the world that's outside of China or
Yeah.
outside of whatever country you're in, and you just have to use the dash uppercase D flag
Hmm.
with a number
Hmm.
that will become the port number of a SOCKS proxy, which you can set up in your browser in 5 minutes.
Right.
And then you just tell your browser to resolve all the DNS names through that, and all the data will go through that SSH connection.
Hmm.
And it's game over.
Yeah.
They will not block SSH anytime soon. That's how you configure securely all the network equipment on the planet.
Sure. But
Yeah.
again, most people are not going to provide you with the other side of that SSH tunnel for free. And in order to
Yeah.
find
But,
people
but you
offering
can
this
get a
service,
VPS. You can get a virtual private server, a
mhm,
VPS service,
yeah,
for literally under $1 a month. I mean, like $10 a year type of deal.
okay. But
Yeah.
that's a little bit beyond the scope of many VPN users that are literally just going to pay money with their credit card and download an app that they run, and they'll just give up their root password because they have no idea what the ramifications of
No,
giving up.
no, but what I'm saying is, even if the Chinese government was able to block all VPN commercial services,
Mhm, which they are, and it's a
yes,
surprise that they don't. And there's
they
probably
would
a good reason
you
why.
would you would now escalate this to somebody who's not selling you a VPN service at all,
Yeah,
but simply any kind of hosting service
yeah,
outside of the country. So
right.
they would have to block that. which is kind of ridiculous. Because, I mean, you could even ask a friend to run it for you.
Right.
Oh, Eric, can you run a Raspberry Pi at home, put it on a separate network or something? Sure. You know what I mean? Like, it's over.
Yeah.
I mean, unless they block every IP and they want to control everything, but it would cause massive, massive problems to their industry, because their industry requires that people be able to SSH into things.
Right.
Right? Like, it's not. It's just part of doing being productive.
No, I'm just observing that when most VPN users, right,
Yeah.
they're not technical enough to set up a virtual private server and then configure it to set up an SSH tunnel and do all of this stuff. So what most people end up doing is they find a VPN provider, and
Yeah.
then they pay money, and then they install the VPN provider's app. And they're basically just completely trusting the VPN provider to be a good actor. And they're assuming that the encryption is actually good. And I'm just saying that you should not rely on.
Yeah, but
Well, you should not give root access to your computer to your VPN provider, obviously, and you should not believe. You should use Tor over a VPN if you're in China. That's what I think. That's probably.
Well, actually, in China, one of the big problems with VPNs is they can recognize the IPs you're connecting to, so it's not secure from that point of view at all.
Yeah.
And then they can also recognize that you're using a VPN encryption protocol, which is not secure at all, especially if there's a law that says you're not allowed to do this, right? Then you're in trouble automatically as soon as you do this, because you're just relying on the fact that the ISP is not looking, basically.
Right.
That's what you're relying on. When I say use SSH, you have plausible deniability. Oh, I was just on a shell transferring files with my server. Who's going to say the opposite?
Right.
Right? You can't tell if that stream is an SSH stream or a web connection to something. There's no way to tell the difference. There's no difference.
Right.
I mean, from the point of view of the middleman.
So could you do SSH connections over two nodes running on a dynamic IP address, presumably behind a NAT table, a network address table?
Absolutely. You can do all of that. And you could even set that up via UPnP, although SSH doesn't have that built in, it doesn't set up UPnP for you. But I mean, it's just a port forwarding thing, really.
Right.
Yeah, you can SSH one host to another. Once you have a SOCKS proxy, okay, if you're a little bit handy with Linux, you can tell IP tables to translate all TCP connections to use that SOCKS proxy.
Right.
And just block UDP completely.
Right.
So at that point, it's over. Actually, that's how I get, for example, you can get Tor at your work. Let's say your work office place, Tor, easy thing. Establish an SSH connection, set up a SOCKS proxy, and then tell Tor to use a SOCKS proxy. Problem solved.
Right.
That's a very useful and practical. I know many people who do this. It's very simple and it's very straightforward. And then you can set up a hidden service, which opens your SSH to something else. So then you can go to some other SSH servers through Tor and then redirect to somewhere else.
Right.
But anyways, it's a trivial matter. And there's even VPS services that you can pay with cryptocurrency. So if you really wanted to be off the grid, you could mine Bitcoins or whatever, right? For up to $10. It might cost you $50 to mine those $10, but whatever. You mine your $10 with $50 of equipment, and at the end of it, you have no names tied to it. You buy your VPS service and you connect to it. Like there's nothing tied to that.
Right.
The root account somewhere with no name on, and you can route traffic through that.
Yeah.
So that's a way. That's an easy, that's a practical way of circumventing all this stuff. Of course, you could I've actually implemented other solutions. Actually, I have on GitHub on my account. There's EWS tunnel, something I wrote, which will tunnel a TCP connection over HTTPS using WebSockets. So
nice.
you just, it looks like a a TLS connection for SSL, basic, like a HTTPS connection, and you can't tell nothing beyond that, right? I mean, and then you can pass SSH through that. You can pass whatever you want through that, and with SSH, you're not just limited to socks. You can also establish layer 2 and layer 3 tunneling technology. So you can go like Ethernet level where you're bridging networks, or you can go tap level where you're just bridging IP networks. So you have like a sort of like a serial cable, between the two networks. Kind of think of it that way.
Yeah, but I mean, the technology that needs to be developed has to be a lot more user friendly than what you're describing, because again, like most journalists, most content creators, and most content consumers are not necessarily going to be able to
what I'm saying,
how GitHub libraries work.
What I'm saying is applying to tech savvy people.
Yeah, of course.
Okay, obviously, and network engineers and that kind of person. Now, it's a trivial matter to take what I just said and turn it into something where you just click a button.
Yeah,
it really is a trivial matter to just produce a setup.exe or whatever, the equivalent for Macintosh.
Yeah,
where you just load this thing and it does all this for you.
Right.
It uses the same protocol. You just can't tell the difference on the wire. Yeah, you can tell obviously on the machine, but you can't tell on the wire what's going on.
Right.
And that's cool. Yeah. So definitely you could just do that. Of course, for anybody interested in security, there is only one way to be absolutely sure that nobody can listen to your traffic in the middle. Only one way. That way is to use a TRNG, true random number generator, generate a file that is precisely the size of the data you're going to transfer, right, on both sides, and then to exchange that data physically, and then to XOR all the values that you send with that data and never to reuse it.
Right.
And destroy it as you're using it.
Yeah. I remember when you talk about true random number generators, you actually you showed me that you built a random number generator using some kind of what was it, radioactive material, americium, I think.
Oh yeah. No, I have a better one than that now, but yeah, you're right. You need a quantum source of noise to do that securely, and there's a lot of them. There's even open source ones that are quite good. So anybody interested in that, just go and Google it. It's not really that hard. You can find a USB device that'll do it, and then you just need some drivers so your OS will actually use that and not the compromised random number generator that's in your CPU. Which, by the way, is the only way to generate secure keys is if you have one of these things, because you cannot generate a secure key if your randomness is not good. That's a fact. So,
okay.
Yeah. So if you're using an Intel chip, the TRNG in there is compromised. So somebody has weakened it on purpose. So whenever you're picking a key, that key is not totally random.
Right.
So there's a risk there. So you have to be aware of that, and if you don't want that risk, then you need to get your own TRNG and hook it up to your machine when you're generating the key, or whenever you're generating any keys, basically. And like I said, the cipher I described is called a Vernam cipher. It's the only cipher known that is truly secure. Is just pure random noise from a quantum source XOR'd with data. That you cannot. There's no cryptanalysis that you can do on that. It just doesn't exist. There's nothing you can do. And in fact, I suspect that's what they're using, for example, to communicate between embassies and countries and things like that. Because
I think you're giving those people way too much credit. I mean, they get hacked all the time, right? There was a
they're running Windows, and You know, you put 20 million lines of C, and it doesn't matter that you're using a Vernam cipher, right?
Right. Yeah.
Yeah. I don't know what to say about that, but you know, there are some machines that are still mechanical that are Vernam ciphers on paper, which destroy the piece of paper basically as it's reading it. And these things I think are still in use because of those reasons. So probably the highest security information still passed with like archaic, you know, mechanisms, which are actually secure even for today, and it will always be secure because the underlying principle is unbreakable.
Well, unfortunately, Eric, I have some serious doubts that people go to those lengths to protect their data. And you know, again, if we look at what organizations like WikiLeaks and certain whistleblowers like Edward Snowden are able to, you know, kind of export from these supposedly secure organizations, we understand that, you know, having centralized data stores makes everybody pretty insecure.
Insecure, yeah. Actually, that's once you collect all the data, you have to protect it, and you can't protect it with the current. Let's face it, the technology today is not able to protect information. It's period. It's not designed that way. Nobody cares about it enough to design it that way, and it will persist like that for a really long time. I'm afraid that even our stuff we're talking about, you know, will be built long before this is solved.
Oh, absolutely. I hope so. I'm just concerned that this crypto winter has defunded certain very interesting projects, specifically like IPFS. I mean, because we know, for example, like I was watching an interview with Jeffrey Hinton, who's one of the godfathers of like artificial neural networks and deep convolutional networks and all this stuff.
Yeah.
He's very influential in the AI community. And he was talking about how he was working on this stuff in the 70s, and it got defunded, and nobody gave a shit until, you know, decades later. Like it went through like a 20 or 30-year winter where like an entire generation of computer scientists just completely didn't give a shit about machine learning. So I know that eventually, like the system that we're describing is fundamentally better than what currently exists. It's just who has a commercial or a financial interest in having it developed.
I think it's going to be, you know, a guy like Gaudi or, you know, any kind of like famous person in history who just did it because they were passionate about it.
Yeah.
I'm afraid that might be the way we're going to see this. So it might take a little longer than we expect, or a little less long. It's really not predictable unless you do it. Unless we're the ones doing this, it's not predictable.
Right. But I mean, the other thing that
Oh. George?